Example 1, part A. Graph r equals 3 cosine theta. Now, if you've been with us at all, you know that this shape is going to be kind of like a circle, but or it is a circle, but it's going to be shifted right. Since the cosine here is positive, it's going to be right. So some things I know about this is a circle, and its direction is going to be to the right. And this 3 is going to be the maximum value. So what I can do real quickly is I can put up here a circle on the graph that will represent what the circle will look like. It'll be not a radius of 3, a diameter of 3 units. And we'll go like that. Now, how did I get that? Let me show you. So first off, this number right here will be our max. So we can determine our max, our value is 3 units. And since it's with cosine, it's going to be to the right. Now, if you did not know that, how would you find it? First thing I would do is I would plug in 3 for r. What you would do is you plug in the max there. And so if the maximum is going to be 3, you would say that 3 equals 3 cosine of theta. And to solve for theta, I would divide by 3. And now I have that 1 equals cosine theta. And the only way to break up a cosine from its theta to get it by itself is to take the inverse. So that means that cosine inverse of 1 equals theta. So basically you're asking yourself, where on the unit circle does cosine equal 1? Well, cosine's x. So if you think on the unit circle, let me go over here and let me take this back. A unit circle would be on the xy axis, you'd only have one circle, and it's 1 unit all the way around. You're asking yourself, where would the x value be positive 1? Here's my x-axis, here's my y-axis. Answer is this spot right there, which that is also the 0 or 2 pi. So I'm going to just go 0 because we usually stop right in front of 2 pi. So it's the value 0. So at theta equals 0, we should have our max. As you can see, it's where theta equals 0 that we have the maximum here. Now, if you want to find the minimum value, which would be a 0, if you want to find the 0, or when r equals 0, you do the same thing. So just the same concept we did here. I'm going to do it again, but this time what I'm going to do is instead of finding the max value by plugging in 3, we'll plug in 0 there. So if I plug that in again, I would say that 0 equals 3 cosine theta. And I go through the same steps. Divide by 3, which gives me 0 equals cosine theta. This time, when I take the inverse, I'm going to be looking for the inverse value of 0, cosine inverse of 0. That'll be equal to theta. So where is my x values equal to 0? So when I look on this, x is 0 here in the middle, and the circle exists there and there. This spot is 3 pi over 2. This spot is pi over 2. So the zeros, these are zeros, there's 2 of them, occur at pi over 2 and 3 pi over 2. And the max occurs, I didn't put that one on there, the maximum occurs at 0. I'll put theta equals 0 so we don't get distracted, so we don't get mixed up. Okay, so I just kind of divide that stuff up. And one other thing we could also find is the symmetry. Now, symmetry, we're going to write one of 3 ways. We're either going to say it's symmetric with respect to the polar axis, the pi over 2, or so either if it's this way, we're going to say it's symmetric with theta equals pi over 2. If it's this way, we'll say it's symmetric with the polar axis, or this way, if it's like the line y equals x, also known as pi over 4, we're going to say it's symmetric to the pole. This one is symmetric with the polar axis. All right, so now let's try this again, and I'll speed it up a little bit. This time we have r equals 3 sine theta, which means this would be a circle. This time it'd be going up. So it'd be going up 3 units. So it should be touching this point at the very highest point. So I'll go here, drag that out. So it goes up to 3 like that. That would be its max. The max R value is 3. We got that from there. We can see the symmetry. This time it's symmetric with respect to theta equals pi over 2. The zeros, to find the zeros, we'd have to plug in 0 in for r. So I'd say that r equals, or 0 in for r, so 3 sine theta. And again, we would divide by 3. Divide by 3 there. And so now I have that 0 equals sine theta. To break the sine of the theta, I would do inverse. So sine inverse of 0 equals theta. Now I'm going to go back to my previous little unit circle I had over here. I want to know this time where the y equals 0. So here's my y-axis. For sine, I want it where it equals 0. Y is 0 here, and on the circle, it's this spot and this spot, which that is 0, and over here, this would be pi. So the values would be 0 and pi for this. So we get theta equals 0 comma pi. That's my zeros. And so that's how my graph would look. And again, it's a circle. So this time, I've got it mixed up a little different. I have that r equals, or r cos theta equals 5. So we'd have to get r by itself. So the first thing we do is we divide by cosine. And by the way, you could type that into your calculator, and it would graph 5 over cos theta. Or we could write it another way. If you remember from earlier in the year, cosine, the denominator, is the same thing as its reciprocal in the numerator. What's cosine's reciprocal? Cosine gets sec c is what we learned. So it'd be secant theta. Now this, in the calculator, if we graph it, is a straight line. And I'll show you why it is. Since it's cosine or secant, it's going either right or left. Since it's positive, it'll be right. So it'll be straight line 5 units to the right. So straight line 5 units to the right. That's how this graph would look. We can see as far as symmetry goes. This time I'm just going to say symmetry. The symmetry, it's cut on the polar axis. That's what cuts it in half. So it has polar axis symmetry. And it does not have a 0 because it does not go through the origin. And nor does it have a max because it continues on forever. Remember, to get the max, it's the distance away from the center. So it just keeps getting larger and larger. So no max R values on this one. Now, why is it that this is a straight line? Well, if you remember earlier, psi y cos x, tangent is y over x. Cosine was x over h. And what I told you at the time is the book actually showed us that it was x over r. And I just demonstrated that h and r were identical. So this was actually the relationship we've been working with. Well, if I wanted to get x by itself, I would multiply both sides by r. And I learned that r cos theta equals x. We'll come over here. What did they originally give me? R cosine, which is the same thing as simply saying x equals 5. It's the same exact thing. That's why it's a vertical line at 5. So now I got one for you to try here.